In this lesson, we're just going to take a look at some problems where we apply the equations of volume for different solids and use those to solve some problems. So in this first warm-up, it says, which has the greater volume? A square pyramid with a height and base edge length of 6 inches, or a cone with a base diameter and height of 6 inches. So in order to answer that question, we would want to find the volume of each of those shapes. So we have the volume of the square pyramid. So volume of the pyramid, that's equal to the area of the base. The area of the base is a square, and it tells us that the base edge is 6 inches. So the area of the square would be 36 times the height. We know that the height is also 6 inches, so 36 times 6. That gives us 218. Or, no, it doesn't. It gives us 216. So that is 216 cubic inches. And then we would want to find the volume of the cone. And we know that the volume of the cone is equal to 1/3 times the area of the base, which is pi r squared. So if the diameter is 6 inches, then r is equal to 3 inches. So we have 1/3 times pi times 3 squared, and then multiply that by the height of 6. So we have 9 times 1/3 is 3, times 6 is 18 pi. I did make one mistake here. We know that the volume of the pyramid should be multiplied by 1/3 as well. So 216 times 1/3, we get 72 cubic inches. So if we want to know which one is bigger, we might want to do 18 times pi. So 18 times pi comes out to be 56.52. So you can see that the pyramid is in fact the bigger of the two. So we're going to just take a look at a few problems here. We're going to use our formulas that we have in order to solve these problems. In the first problem, it says the volume of this right triangle prism is 1,440 cubic centimeters. Find the height of the prism. So it is a triangular prism. We know that the volume is equal to the area of the base times the height for any prism. And so we know that the base here is a triangle. So if we replace this, we have volume equals 1/2 times the base of the triangle times the height of the triangle times the height of the pyramid. We know that the base of the triangle is 8, the height is 15, and we know the volume is 1440. So we have 1440 equals 1/2 times 8 times 15 times the height of, which is what we want to find. So half of 8 is 4. 4 times 50 is 60, or 4 times 15 is 60. So we have 1,440 times, or equals 60h. So 1,440 divided by 60 is equal to 24. So the height of this pyramid would be this prism would be 24 centimeters. In example B, you'll see that the volume of this sector of a right cylinder is 2,814 cubic meters. It says to find the radius of the base of the cylinder. So we're trying to find the radius of the entire cylinder. We're not just talking about the sector in this case. And so we want to find that to the nearest meter. So if we think about this, we would need to figure out what percentage of the cylinder we're looking at with this sector. We see that this sector has a 40-degree angle. So that means we know that this is 1/9 of the volume of the total cylinder. So we know that the volume of a cylinder is volume equals the base times the height of the cylinder, the area of the base times the height of the cylinder. But we know that the volume we're given is only 1/9 of that. So we're going to divide the volume of the cylinder by 9. So we know that the area of the base in this case is a circle, so it's pi r squared times the height of the cylinder divided by 9. And if we fill in what we know the volume is 2,814, so that goes in for V, so 2,814 is equal to pi times r squared, which is what we're trying to find r, times the height of the prism, which is 14, divided by 9. First step, we would multiply by 9 on both sides. So 2,814 times 9 would give us 25,326. That's equal to 14 pi times r squared. I'm going to divide that by 14 pi, and that gives us r squared is equal to approximately 576.11. We would like to find out what the radius is, so we take the square root of both sides, and we get r is equal to, I believe that comes out to be, give me 1 second, 24.00 if we round, so the answer would be 24 meters for the radius of that cylinder. The next example tells us that we have the volume of a cone, which is 30 pi cubic centimeters. It tells us the height is 10 centimeters, and we would like to find the diameter of the base. So we know the volume of a cone is equal to 1/3 times the area of the base times the height. We know the base of a cone is a circle, so we have volume equals 1/3 times pi times r squared times the height of the cone. And if we use the information we're given, we have 30 pi is equal to pi times r squared times 10. So we're going to divide both sides by 10 pi. That gives us 3 is equal to r squared. And if we take the square root of both sides, we get r is equal to the square root of 3. And after that, we want to find the diameter of the base. So we know the diameter is 2r, which would give us 2 square roots of 3 for our diameter of this cone. The final example requires us to pay attention to the fact that we need our units of measure to be all in the same unit in order to get a correct answer for this. So if you read this, it says decorative red mulch is to be spaced 6 inches deep in each of the beds shown above. Mulch is sold in bags that have 1 cubic yard. To the nearest cubic yard, how much mulch will need to be purchased? So we need to figure out the volume of mulch that goes in these 3 rectangular flower beds plus the volume of mulch that goes in this circular flower bed. And so if you think about this, if we're filling in mulch, the rectangles create rectangular prisms, and the circular flower bed creates a cylinder. So we need to find those volumes. Now, what we need to keep in mind is that the flower beds, their measurements are given to us in feet. The bags of mulch are given to us in cubic yards, and the number of the depth of the mulch is given to us in inches. Now, to save us from using too many fractions, what I'm going to do is I'm going to change the number of cubic yards into feet. So if you think about this, if you have a cube and that cube has a volume of 1 cubic yard, that means it's 1 yard by 1 yard by 1 yard. So if we want to change this to feet, 1 yard is 3 feet by 3 feet by 3 feet. So if we wanted to find the volume of that 1 cubic yard, that'd be 3 times 3 times 3, which would give us 27 cubic feet. So 27 cubic feet is equal to 1 cubic yard. So we have the bags of mulch in feet, and then we have the flower beds in feet. Now we need to write 6 inches as feet, so that'd be 0.5 feet. So now that everything is in the same unit, we are good to go. We need to find the volume of the two long rectangular flower beds, so here and here. So you have 2 feet times 25 feet times 0.5 feet. That gives us 50 times 0.5, which is 25 feet. But there are 2 of those flower beds. So 2 times 25 gives us 50. So we have 50 cubic feet for the 2 long rectangle flower beds. We'll abbreviate flower beds FB. For the wider flower bed, you would have 4 times 25 times 0.5. So 4 times 25 is 100. 100 times 0.5 is 50. So you have 50 cubic feet for this flower bed as well. So you have 50 cubic feet for the 2 long ones, 50 cubic feet for the wider flower bed. And then for the cylinder, we would have the volume is equal to pi times 7.5 squared, so pi r squared, times the height, which would be 0.5. So we have 7.5 squared. Hold on, my calculator didn't reset. 7.5 squared times 0.5. So we get 28.125 times pi. And for this problem, we're going to multiply 28.125 by pi, because if you go to Lowe's or Home Depot and tell them that you need 28.125 pi cubic feet of mulch, the person there probably will have no idea what you're talking about. So multiply that by pi, and that gives you 88.3 cubic feet. So the total amount of mulch we need is 50 and 50, which is 100, plus 88.3. So we need 188.3 cubic feet of mulch. It comes in bags that are 27 cubic feet big. So you have 188.3 divided by 27 cubic feet. And that gives us, 188.3 divided by 27. It gives us 6.9 bags of mulch. You can't do that. You have to buy whole bags of mulch. They don't give you partial bags. So that means you need 7 bags of mulch. So go ahead and begin looking at the problems. The problems in the homework are similar to these ones that we did in these notes. So if you have any questions, email me, message me on Remind, or ask me the next day.